My name is Muhammad Afiq, distress engineer assigned for finite element analysis in MIR-Valve. Using ANSYS software, a set of internal and external pressure are applied to the design to determine the integrity before proceeding to the actual build-up of the valve. I'm using the FEA software ANSYS for the 20-inch Class 300 subsea ball valve for Sapura Offshore Sdn Bhd.
My name's Tony Church and I'm the Senior Plant Manufacturing Manager for MIR-Valve Malaysia. Today we will be talking about this valve here, which is a 20-inch Class 300 subsea valve. Material of construction is carbon steel body with full 625 Inconel inlay. The valve will be operating at a depth of 40 meters subsea. Design and manufacture is to API 6D SS. I will introduce you to Bob, our QC inspector, who is performing some of the critical inspection. For the inspection on this particular body, we are using a Farrar, which is basically a portable coordinate measuring machine. The reason we use the coordinate measuring machine instead of standard instruments like vernier calipers and micrometers is for the repeatability, accuracy, and the checking and relationship of dimensions. So for example, we can check hole positions where the bonnet will bolt to the body of the ball valve. We can check concentricity between key location diameters, so we can ensure the bolt holes will line up, the seat pocket is in line with the ball. These are all critical features that must be checked to ensure we have a reliable product when we assemble the valve.
My name is Andrew Pang. I'm the head of engineering at MIR-Valve. The valve that we're testing beside us today is the 20-inch Class 300 top entry subsea ball valve. It's got a forged body and metal seats. The client is Sapura Offshore and the end user is Brunei Shell Petroleum. Sapura Offshore has chosen to put this valve through a series of tests lasting 5 days. They can be categorized into these categories: shell tests, seat tests, drivetrain tests, and several supplementary tests that the client has chosen to do. Now, this is a subsea valve, which means that it is going to be installed immersed in the ocean. Subsea valves are made with environmental seals, which keeps the seawater from getting into the valve. Obviously, the deeper the valve is installed in the ocean, the higher the pressure the valve will experience. Here at MIR-Valve, we have come up with a way to test the environmental seals without the use of a hyperbaric chamber, by building the test facility into the valve itself. Of course, this confers a significant amount of advantages for our clients, especially in terms of monetary and time cost to the project. This feature built into the valve allows the testing of the environmental seals wherever the valve goes, both in the factory and outside of the factory. Also in situ, where the client installs the valve. And when all of the tests are done, all the ports will be plugged and seal welded. And this test allows us to ensure that the seal welds are of a high integrity.
After 4 days of testing in the bench, we are coming towards the end of this FAT. We are now standing at the submerged tank. So the tank is full of treated water. We have a corrosion inhibitor in the water. You can see now the valve is fitted with blind flanges. The valve will be lowered into the water tank and fully submerged. We will then introduce nitrogen gas at a pressure of 57 bar or 825 psi. The pressure must be held for 6 hours, and during the 6 hours no bubbles are allowed to come from any part of the valve or any of the fittings attached to the valve. If any bubbles are seen during the test will need to be repeated.